We're looking at question 5. It says the capacitance of a parallel plate capacitor A decreases when the temperature between the plates decreases. B increases when the potential difference between the plates is increased. C is greater without a dielectric between the plates than with dielectric. D is greater with dielectric between the plates than without dielectric. So now to answer this question, we need to first know the formula for capacitance. So now capacitance C can be equal to Q over V, or the constant, let me just represent it by capital E, O times the dielectric constant and then times the A all over D, the distance. So now let's analyze each options. A decreases when the temperature between the plates decreases. Now when the temperature between the plates decreases, it doesn't have a direct effect. It is not that much. It's very minimal, and it only, even if it could affect, it is at very high temperatures, which will only cause contraction and expansion, and that is not considered here. So now B increases when the potential difference between the plates is increased. So now let's say this is your capacitance. Now when the potential difference is increased, it doesn't have an effect because the charge will increase proportionally, because the capacitance of a specific capacitor is constant. And then C says is greater without a dielectric between the plates than with a dielectric. Now without a dielectric, it means either it is in a vacuum or air. So now when it's in vacuum or air, the dielectric constant ER in air or glass is always equal to 1 or near 1. So when it's without a dielectric, the ER is 1, which isn't greater considering option D, which we'll soon study. And then D says is greater with dielectric between the plates than without dielectric. That is the answer. With a dielectric, let's say for ceramic or mica, the dielectric will actually be higher because the ER, dielectric constant, is greater than 1. So when it's greater than 1, this will lead to this. So now there are important points to mention. Let's see the things that increases capacitance are the area. If the area increases, capacitance increases, and also if the dielectric constant increases, it also increases. But another thing that decreases this thing is the distance. If the distance increases, if the distance increases, the capacitance reduces. So now that's all for this number 5 question. We'll move on to the next one.